Weather patterns and the water cycle, how the sky works. On a warm afternoon, you step off the bus dry and arrive home under sudden rain. What flipped the sky so fast? We're untangling how water and air team up to make weather patterns, the water cycle, and the winds that shape your day. After today, you'll be able to explain where clouds and hail come from and why coastal towns feel milder than places far inland. Here's the simple version. Sunlight pours energy into Earth, and that energy moves water and air. Water keeps cycling. That's the water cycle, the continuous movement of water on, above, and below Earth's surface. Most of this action happens in the troposphere, the lowest layer of the atmosphere, where we live and weather happens. That's the layer where clouds, rain, and storms do their thing. Warmth gives surface water enough energy to escape as invisible gas in the air. That step is called evaporation, water leaving a surface for the atmosphere. Lakes, oceans, puddles, and even wet sidewalks all feed vapor to the air. A puddle shrinking on a sunny sidewalk is evaporation in real life. Plants join the flow too, releasing water vapor through tiny openings in leaves. That plant release is transpiration, basically plants breathing out moisture. Walk through a dense forest after rain, and the air feels extra moist because of transpiration. Higher up, the air gets cooler. Cooler air can't hold as much water vapor, so vapor turns into tiny liquid droplets. That change is condensation, and billions of droplets gather as a cloud. It's like a cold soda can fogging up. The same condensation happens in the sky. How much water vapor the air is carrying is called humidity, a measure of moisture in the air. On sticky days, humidity is high, and even your sweat evaporates slowly. Now, what moves storms around? Wind does, the large-scale movement of air from areas of higher pressure to lower pressure. Air pressure is simply how hard the air presses on a surface. The bigger the pressure difference, the stronger the wind. In a high-pressure system, air is denser and sinking. Sinking air warms and dries, which is why high pressure usually brings clear skies. In a low-pressure system, air is rising and cooling, often helping clouds and storms grow. Inside clouds, droplets bump, merge, and grow until gravity wins, and they fall. Falling water from clouds is precipitation: rain, snow, sleet, or hail. Cold air favors snow and hail, while warmer air tends to produce rain. Hail, the hard ice pellets, meets powerful thunderstorms with strong updrafts. Those storms build in towering cumulonimbus clouds, giant anvils that reach high into the troposphere. Updrafts fling little ice pieces up and down, layering them with ice until they're heavy enough to crash to the ground. Once water lands, it has two main paths on the ground. Water flowing over the surface is runoff, like sheets of water racing down a street. Water soaking into the ground is infiltration, slipping between soil grains to refill underground water. A driveway sends more runoff. A garden bed with loose soil allows more infiltration. Some of that underground water slowly feeds streams and wetlands long after the storm. Big water shapes weather too. Oceans warm up and cool down slowly, so they smooth out temperature swings near the coast. That moderation keeps summers cooler and winters milder in beach towns compared to far inland. Walk from a breezy pier to a neighborhood miles inland, and you'll feel the difference. Put it all together, the sun drives evaporation and transpiration, loading the air with water vapor. Cooling causes condensation, building clouds. Droplets grow into precipitation that returns water to the surface. Runoff and infiltration carry that water across and into the land, closing the loop. Meanwhile, winds and pressure systems steer where clouds and storms travel, and high pressure favors clear skies. Oceans help keep coastal temperatures steadier. Sunlight drives evaporation and transpiration. Cooling causes condensation in clouds. Precipitation returns water. On land, runoff and infiltration move it. Winds and pressure steer storms. Oceans keep coasts milder. Step outside, feel the humidity and wind, and call the next hour's weather.